Good morning, good evening, or good afternoon, actually, wherever you might be. Happy Wednesday, everybody. Keith, ZC, Smab UK, so nice to see all of you already. Wow, we got people already in the chat before me going live. Got my coffee ready. Got a programming space set up. We're about to read through day 7. Day 7. There was a post on Reddit yesterday that basically someone had analyzed the difficulty of the problems over the last so many years. Essentially there was like several memes saying, here comes the hard one. I haven't read through it yet completely, but it looks like it's gonna be a fun one today. I'm excited. It looks like we're doing something with artificial system or something like that. Well, anyway, we're gonna take a look. Yeah, Smab. Yesterday was I don't know, disappointing. Let's say disappointing. It was, well, I was excited about yesterday's, actually. After the first part, I was like, oh, there's going to be some really cool, some tricky algorithm I'm going to have to write for the second part. I really was thinking the second part was going to say, okay, now, not only, you got to find the end transmission marker, which happens to be a thing that has, some very specific requirements that you have to do something clever and prevents you from, have to do something clever so that your program will finish before the heat death of the universe, essentially. Okay, let's look at day 7 here. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. No space left on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output. For example, the file system consists of a tree of files and directories which can contain other directories or files. All right, so typical file system here. The outermost directory is called /. This is root. You can navigate around the file system, moving into or out of directories and listing the contents of the directories you're currently in. Within the terminal output lines that begin with $sign are commands you executed, very much like some modern computer systems. All right, I know what CD does. I know what LS does. Given the commands and output above, you can determine the file system looks visually here. All right, so we're gonna have a file structure. Tree, probably use a tree, or a hash map might work as well for keeping track of full path names. Here there are 4 directories. These directories contain files of various sizes. Yep. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. Total size of a directory is the sum of the size of the files it contains directly or indirectly. All right, so recursively build up the size. Total size of the directories can be found as follows. Make sure there's no tricky bits in here. Directory E 584, that makes sense. Directory A has 94853 because it contains files F, G, and H, plus indirectly I contains E and I. Yeah, so it's the sum of all of the parts contained within. To begin, find all the directories that with the total size of at most, what is this? 100,000. Then calculate the sum of their total sizes. Okay, not too bad, not too bad. So my thought here is, do I want to actually build out a whole tree structure, or do I want to just use a dictionary? Because there's a trick here. There's a trick here. Ooh, a fun one might even be to read these commands and actually write them to your file system. So you could potentially pass this into like some kind of bash. All right, I'm gonna do this. I'm not gonna do it this way, but I'm gonna probably do it this way later because I think it'll be fun, where you actually take this input and you write files to your computer that happen. The hard part is making sure, I don't know if hard part, but the tricky bit is making sure they're the exact correct size, which you could do just by doing like a byte stream of that size. And then you can use your system to just say, hey, how big? You use the find and sort command to do this. That could be fun. Yeah, do I want to do a dictionary or do I want to do an actual tree structure? So my gut is kind of telling me the easy way is going to be to use a dictionary. ZC is saying use a dictionary. But I don't know what the second part of the puzzle. The second part of the puzzle, it might be nice to have the tree structure. Yeah, have some giant files. Funny, that makes me nervous about part 2. Let's see my puzzle input. How bad does it get? Oh boy. That's funny. That's funny. Okay, it looks like we don't have to parse full //slashes. If I do it using a dictionary, I'm gonna do, let's think here. CC wants me to do it with a dictionary, so I'm gonna do it using a dictionary. All right, we're gonna do it the. I'm gonna regret this, aren't I? Has anyone here completed it? Someone tell me, am I gonna regret using a dictionary, or should I do it the appropriately engineered way? The appropriately engineered way would just to have a tree structure. It's probably what I should do. No spoilers. All right, I'm too scared to do it with a dictionary. So sorry, ZC. I'm gonna do it. I'm gonna do the fully engineered, air quotes, fully engineered way. So I'm gonna create a data type called like file or file ref, like this. And so this is just going to be a class file reference, and so I think I kind of need two things. So ideally, or I could just say tree of things. Let's not get too crazy. We've got a recursive data type here, and then it's going to have a field, which happens to be a list of other file refs. And essentially I just need to be able to determine the size. I need to be able to add and determine the size of these things, children. And we'll make that a property. I need to be able to add children, so public And for funsies, I'm gonna make it return a reference to itself. Add child, file ref, child. We'll make this have an initializer. For fun, this will just return itself. Let's get ourselves a constructor. Need to know whether or not it's a dictionary or not. So my thought here is, should I make this should I engineer it smart and have sort of two classes here, a subclass, one that's an actual file, so maybe not file ref, but my brain can't think of a good word for something that's both it could be either a directory or something, a directory or a file. We'll actually just say that a directory is a type of file. Need to put in a net here. And we'll say that children equals new. So we have a list of children, starts empty. And then we want, this will be public. Public, int size. This will also have a getter. And that's where the recursion's gonna happen. So our file ref here, we can take in a default size as well, but we also have to calculate it. So I'm gonna write a helper here, private int. The name is an inode, not that I use that name, inode. Yeah, I was thinking about node. So what I really should what I could do is if I had a generic tree type, so I could have tree and then just have a tree of the union type of files and directories. That's essentially what it is. I'm gonna call this helper calculate size. And for now, it's going to turn 0. And we might memoize this later. The problem with memoizing it is if you make changes to the subchildren, it becomes a problem. We'll have a size here as well. Int base size. Oh, I'm already doing a poor job engineering this, aren't I? All right, we're gonna make this abstract. And size is gonna be abstract. And we're gonna have another class, directory. And directories are gonna have children, but folders are not gonna have children. So public class directory extends file ref. Because directory has no size built in, its size is determined by its children. What is it complaining about? What did I do? Oh, it needs my size. Public int size get, and the get is going to be calculated from a calculate size and add children. Okay, so directories can have children added to it. What is this? Declared types and namespaces. What abstract member am I missing? Oh, I gotta put override in there. Thank you, compiler, for yelling at me enough. I always tell my students, your friends don't lie to you. The compiler is your friend. Just remember that the compiler doesn't lie to you, and your friends don't lie to you. Therefore, the compiler is your friend. A lot of my students hate compiler message, and I just tell them, no, they're your friend. They're your friend. The compiler is telling you the truth. Here's how you do it. And then sometimes you get some crazy error messages that aren't actually related, and your friend's trying to help you, so don't be too mad when the compilers can't help you. Yeah. So file ref size. This is designing, constructing these things is, I boil away at like, what is the right design? Yeah, exactly, Keith. Your quirky, obscure, nerdy friend who loves to go off on a tangent about whatever topic they don't get in their head. That's right. I do the same thing. I teach, or have. I actually went to school initially. I have a music degree, a music education degree. I wanted to be a band director. That didn't turn out well. But I used to tell students the same thing about the metronome. You gotta practice the metronome. They say, I hate practicing with the metronome because it's clicking at you. And I'm like, the metronome's your friend. It doesn't lie. It tells you when you're wrong. All right, add child. Let's do an actual file. The file should be easy. File. So I'm overloading the namespace here. Is there, if I do, file ref. We'll call it elf file. I don't want it to conflict with the system.file. And I imagine there's a system.directory. Let's change this to elf directory. Just to make sure I'm not clobbering some name that already exists. Public class elf file sends file ref. And this one's easy. This one's basically a record. And we do, we make this a get init. I'm gonna regret not having get child in all of these, aren't I? Can I override because, oh, well. Can I do a private set? I can't. This is fascinating. Interesting. I didn't realize you couldn't do that. Does this mean, all right, public elf file int size, this dot size, and this should be, style cop would yell at me here. And then get, how am I not getting file ref .NET build? I feel like this should be an error, yeah. Main method suitable for an entry point. Console.writeLine hello world. I really feel, this is kind of wild to me. I don't understand this here. Someone yell at me, tell me what's going on. I'm really amazed I can set this here even though it doesn't say it has a set ability. I'm pretty confused, but I'll leave it alone. If it's gonna work, can I construct one of these? Elf file f equals new elf file. Ooh, I'm missing a path name. I need to get a name on these too. Public string path, and in here we'll do public string path do this dot path equals path. Add that to our constructor string. For some reason, path feels like it should go first. I wish I had can I generate toString generate C# generate. And I know in Visual Studio I could do a generate here, but override string toString. We just want to be able to see this guy here, and we're gonna say elf file path and size. Or I could even make it match file size. I'm gonna go with this for now. Let's see. All right, so let's make sure this works. Elf file bob.txt, bob/slob.txt. Let's give this a size of 500. Right line F. Just make sure this makes sense. Oops, .NET run. That is so bizarre to me. I didn't realize you could set these. I think you can only do it in the constructor, right? This dot size equals 7. Yeah, only in the constructor. So I guess by default they have like the init keyword in there or something. You don't have to be explicit about it. I'm kind of amazed by that. Override. I'm gonna make it abstract. Oh, this one doesn't have to be abstract. Public. Yeah, so Smab, I thought you needed to specify that there was like an init thing here, but I guess not. Which is interesting to me. I didn't realize that you couldn't do that. I'm still, like I've said before, I'm pretty new to C#. I think I have under 1,000 hours of programming in C#. So I definitely consider myself mostly novice. I have probably 30,000 hours worth of programming in general. But it's all about what am I doing specifically. There we go. Base path. There was one, I had a student calculate it based on some information I gave him, I think last year. I don't know how close it was. I think it was like 36, an estimation of 36,000 programming hours in my lifetime. It's quite a few. There is no argument given that corresponds with the formal argument path. Yes. Base path. String path. Like that. There's no, can't give a size to an elf directory, but an elf directory has children, and then we can calculate the size by basically getting the sum of all of our children. So it'd be return children dot what is it here? I want to do sum. Ooh, I can do children dot sum. Cool. Select C dot size dot sum. Hey. Yeah, I thought about doing a record. I should really have done that. I was thinking records. I was thinking I should have done a record initially. That's what I've done in the past. And then, so let me ask, can records have methods? Can you do methods on records? So I'm used to records being sort of immutable data type that, okay, so I should have done a record. I should have done a record, thank you. Can I switch it? How hard would it be record? Can you do abstract records? Oh man, this is the way to go. Oh, give me that record. I did not. So you learn. See, this is why you stream while you code, because you learn from people who know way more than you. Oh, something went wrong with my path here. Oh, I would do string path like this. Here, let's see how we do. And then here I do base path. I can get rid of my toString. Oh, but now my my size is gonna be weird, isn't it? No, it's not. Oh man. Oh, this is beautiful. Why would I ever use a class? Why would I ever use a class? Oh, thank you so much. Specifying overrides in the constructor. Interesting. Okay, well, I'm pretty happy with this. We got our elf file loaded in there. Can calculate the size. Now I'm 90% sure, and I've probably missed something. All right, so this actually just becomes, I don't need this private thing here. I'm pretty sure it's just the sum of my children. Oh, I need to actually add a child. So this would just be children dot add child. Oh, you're right. You're right. Even better. Even better. So I don't even need this init here. Why is this an option? Can someone tell me why init here is an option if I don't? Am I just not understanding what init does? I thought if you wanted to initialize it in your constructor, you needed that. And in fact, I can just do new here. And this is our empty boy. Yeah. Ooh, I don't like that. I don't like that because I can modify this list outside. So we're gonna make this private. We're gonna make that private because I don't want people adding things to my list outside of here. And instead we need to sort of get a, like an iterator over it. Yeah. So public list file ref. No. I enumerable file ref. Oh, that's right. That's right. You do the weird thing. I guess it's not weird in C# when you're constructing it. You put the curly braces on the during the construction. I know. Okay, cool. That makes sense. I remember that. I don't use that very often, but I've seen it used. So should I make this get children? What would be the C#y way? Enumerable. So I think this is what I want. I know. If it's a method, shouldn't I still have get there? What it should be is it should be a property, right? Ban yourself from using the word get in C#. Um, so it's saying here, I think this is what I want. List of this dot enumerator. Oh, it doesn't like, let me hang on. Is that right? I don't know. If it was a, I think if I'm gonna make it a that's true. That's true. That's very true. All right, so this actually here though, this is private, so it should be underscore children, which will let me do children. And my brain's doing a weird thing. Does anyone's brain ever do something weird where I know this word is spelled right, but it looks super weird to me? All right, thank you, Keith, for helping me be a better human. I appreciate that very much. Part of me thinks if I were to do this now, that we would be good to go. All right, let's try it. Let's see if we can parse in some commands. So I'm gonna have, we're gonna start with an elf directory, root equals new elf directory. And we kind of need a, when we cd into stuff. So my question, so I think maybe I'll do a recursive parse. That might be what I do so that I can like sort of pop back and forth between these things. Either that or I can use an explicit stack on the side and do a loop that just says chunk through all of the input as we go. File, or we're gonna do, or maybe have a queue of string output or input equals new, or let's do file dot read all lines input.txt.toQ. There's no 2Q. Dot to array. Hang on, and then can I just construct a queue, new queue? Can a queue take this? There we go. And it's just telling me that I should do it that way. I like key solution, but I'm also really happy with mine. Okay. And then I'm just gonna say, well, my queue, well, or do I want a recursive? I'm gonna do a recursive. Do I want to do recursive? All right, void. We'll do recursive. Build tree. Build file system. And we're just gonna have this take in a queue. Commands. Like so. And then we're gonna say, gonna have it, if we cd elf directory, current working directory. So this is our current working directory. So that way when we get files, we can just pull those out into it. And just for fun, we'll do process line. Process line, yeah. So it's gonna take a single command, an elf directory, current working directory, and we're just gonna handle that. So then we're just going to sort of switch on these things. If I guess I should parse these as commands actually a little bit. It's a little bit helpful. CD we care about, and I don't think we care about ls. We care about these, we care about CD. I think that's it. I don't think we actually care about anything else. All right, so I'm gonna build a few more record types. New file, command here. We'll have a couple records. We'll have a record that is a command. So we need to change directory. All right, so we have command, and the idea is we have public abstract. Johnny boy, welcome back to the ship. Glad to see you here. Command, it needs to have a way to operate on. Am I totally overthinking this? The recursive solution here actually I think is really annoying to implement. Usually a recursive solution feels good to me, but this is feeling kind of bad to me. I think I should just use an explicit stack to keep track of sort of where I am in my file structure, which will make it, I think, actually make it a little bit easier. I'm gonna try that. So I'm gonna have a stack of elf directories. This is just gonna be where my current working directory is. Paths like this. And then I'm just gonna push on to it. Path.push root. And then I'm just gonna sort of, I think I'm gonna do well input dot count greater than 0, string input equals string command equals input dot pop, input dot dq. Take the first input, we're gonna process it. We still have to split it. This didn't solve my problem. I really just want a command like this. And we'll have something that's like parse. Hang on, we have our input like this. And we're just gonna parse out whether it's a CD or one of these things. I want to do this in the nice object-orient-esque way. So to do this, I need to know whether or not I need to move into a path and whether I have children. Okay. So there's two types of commands. There is a command that is a change directory command, child, like this. And then there's also a add file command, which change directory command is actually going to have an elf directory, elfdir, and then we're gonna have an add file, which is gonna have an elf file, and this is gonna be a file. Call this dir. We'll call that file, and then we have a record that is like a no-op command. All right, so I want this one just does nothing. So that's gonna be for all of the, just for ease of use, all of the things that we don't need. So these LS's get ignored. So we got CDs to LS. I guess I could have an LS list command, and it's going to do nothing. But the idea is, how does this change what we're doing? I don't think it changes all that much. I feel like maybe I'm really overthinking this, but let's add in a parse here. So we want an input. All right, for now I'm gonna do it this way. Oh, I don't even need those because there's no body, but these all are commands. Is there a match? Does C# have like pattern matching? I'm doing this in such a silly way. There are pattern matching. Oh man. Oh man. I want a pattern match on records. C# pattern match records. That's really what I want to do. Compare discrete. Records. Does it allow me to pattern match type other types? Record. Oh, I was there. I just went the wrong way. Multiple inputs. What I want to do, let me see if I can just write out what I want to do and figure it out. I want to up a bit. It's the delay is probably killing us here a little bit. Type. Presenting positional record type declares 2 members, but I want to be able to do it on sort of my subclass. Up a lot. All right, there's so much. I don't want to be too. Type test. Another company is preparing to test a variable, see if it matches a given type. For example, the following code tests. If we have one here, the declaration doesn't match a null. Well, but this is just sequence is null. It's not quite what I want. I want some nice pattern matching syntax so I can avoid writing a subclass. I think really what I want to do is be able to do something like command C equals parse command C, and then do C dot apply, and this is gonna take in my paths stack and just sort of do what it takes in, like my file system, and does whatever is necessary. I think that's what I want to do. I think I want to have an apply command, and each subclass does the specific apply, and then my loop sort of becomes relatively easy here based on this subclass implementation. Unless I'm missing something, and so like in Haskell, I could do the following, like match. If I had a command C, I could do match C, and then I could do something along the lines of change directory command. So this would, goes to, and then I do something over here. This is the type of pattern matching I would like to do. This is Haskell OCaml style pattern matching. Not really the OO style pattern matching. If someone can send me an example of that, that would be something new I could learn about C#. But this is sort of what I would want to be able to do with a match. Shank, is it? I don't want to pronounce it wrong here. Shank, I'm seeing it as Shanky the Banky. But I can do that on, all right, let's try it. C, switch, Shanky the Banky, we are doing this var x equals 0, 1, 2. C is not defined, let's try equals. Sorry, Shanky, let me see if I can get a response to you real quick. List command, comma, comma, comma. Oh, you can do this. Okay. Okay, very nice. Shanky the Banky, we are doing Advent of Code. Day 7, no space left. You're watching me sweat my way through building a file system structure. I'm going about this probably the hard way hard way is not the right, I don't think quite what I would call it, but in a way that is not necessarily, I'm calling it the semi-over-engineered approach. Semi-over-engineered approach. And I guess you could also call it Twitch codes, because all of these people here in the chat are telling me what to do, giving me advice, which I am totally appreciating it. But thank you for stopping by. We are building essentially a file system to solve this puzzle. Okay, so this is what I wanted. This is nice. This is nice. If I add a name after the type, it will introduce a variable of that type. Cool. All right, so I think I do. So I think I've decided the object-oriented way is to do it this way, though. So I think I'm gonna go ahead and do that in that regard. I am really happy that you can do this with record matching. That's super cool. I'm totally gonna add that into. I teach kids C#, young students C#. This is such a great way to break down a problem that I'm probably gonna help my students or teach my students this. All right. So, but I do want a parse command here. I'll comment this out. And so in my commands, we're gonna add in a public static command utils static class. And we're just gonna have a public static command parse command string input. That it makes me so excited to know that C# has pattern matching. That's my favorite part of OCaml and Haskell. I mean, I guess you couldn't do anything without pattern matching in those languages. Not anything, but it'd be much harder. All right, so we're gonna say if input dot starts with $cd, we're gonna get our change directory command. Else if input dot starts with ls, the add file command, yeah. This is interesting. Else if we have to check if it starts with a number. All right, let's do the following. I'm gonna tokenize it. Input.split string tokens, and we're gonna say if tokens1 is CD, if tokens1 is LS, if tokens0 is dir, else if int dot try parse tokens1 out int size tokens at 0, else throw new exception, something terrible has happened. All right. So the idea is we can parse in commands. It's going to return it down here. It's going to return a file. Yeah, add file command. We need an elf file here. All right, so throw new exception, not implemented. Is there a not implemented? Not implemented exception. There we go. Go ahead and do these for now. The CD one, we're gonna parse that in. We're gonna get the third token, 012. There's a dir called CD. Ooh, thank you. That's absolutely true, because I skipped that. All right, I'm gonna go back to the starts with. I actually like the start with. If tokens 0 equals $, and thank you for that. Probably saved me some real pain. I think they're probably randomly generated, so you actually won't. Oh yeah, you might. Yeah, I think they're randomly generated. You absolutely could get a dir CD. Here, let's see, dir CD. I don't have one. I don't have one, but it would be really easy to dir ls. I have some that start with ls, but no dir ls's either. Great point. Nice little check there. I appreciate that save. And if this is the case, what's interesting here is I need a reference to this elf directory itself. So I need, so later on, I need to make sure I'm putting things in the correct elf directory. Yeah, because if I'm going to add this to my child, my CD here needs to get this directory from somewhere. So I need a way to like access my elf directories that have been created so that I'm referencing the right ones. So it's almost like my file. I need a like file system registry to be able to do that. So I'm gonna cheat a little bit. Cheat might not be the right word. Semi-random. I think from talking with Eric and previous that he has a bunch of set data sets that are tested by volunteers. That's pretty good. I like that, because what if you had a bad generation? And so this should be command utils dot parse command command. Oh, and I already had a C here. Yeah, you'd be in a lot of trouble if you got some input that just didn't work. If your generation was wrong, that would be really, really annoying and frustrating. Yeah, I think I need a registry of my file paths. I need something like this. Dictionary from string to elf directory registry. So I need a way to get it out, because the idea is when I encounter it for CD, I've already added it. I should have added it to the parent folder. So this feels a little bit bad to have to pass this in here, but I'm okay with it for now. We're gonna keep moving. It's gonna be a little bit hacky. Makes me wish maybe I'd just done the dictionary version. So what we need to do is we're gonna return a change directory command with the elf directory that's in our registry registry at tokens of 2, which is the path. Ooh, that's not gonna work because we actually have to add the whole parent path to it as well. Oh, it's a little bit annoying. So I actually think I need to pass in my parse command needs to know my current working directory as well. I hate this. So the full path to this token, so it's going to be string full path is equal to cwd dot path plus tokens at 2, and then we look up our full path like this. I really dislike this, although, and this should be elf directories. Change directory command. What's the annoyance here? Oh, actually, new. There we go. Yeah, I need to be able to get that back. Eric was actually on earlier today watching various streamers. Seems he comes to Twitch to see people's pain. That's the way to do it. If you make something, you want to watch people do it. Absolutely. All right, I'm gonna make this wider. I'm getting tired of scooching back and forth. I hate that I have to pass all of these things in here to do it. If I was for my tutorial video, I'll probably find a nicer way to refactor this into something that's a little bit better, but I'm gonna keep moving here. ls does nothing, so ls is easy to return. List command, new. What's it saying here? The command, oh, these have to be public. Public. All right. So, I mean, that's why you guys are here too. You like to watch people, you like to watch me suffer through a solution to these, right? If we have a dir, we actually construct a new directory. All right, so we're gonna say new elf directory, full path. All right, so this is gonna be similar to this, but our directory should be the second token, so token 1. Like that. We create a new elf directory, child, and then we're gonna do our cwd. Here's the worst thing about what's happening right now. This is no longer a parse command. This is like an apply. I'm writing this all out, which I'm hating, and that's making me sad. So I might call this process command because that's what I'm doing. So this becomes cwd dot add child. So I should have done the switch to begin with. Or change directory here's how I'll do it. Change directory takes in path. That's what we'll do. All right. So now I don't have to take in my CWD or my dictionary here. There we go. All right, so this is just gonna be a basic return new change directory command, and it takes in the proper token. A lot of Rust streamers. Yeah, Rust is a really cool language. I'm so happy that functional programming is sort of catching up. I love functional programming. It's super. Yeah, this should be. If token starts with dir. All right, so we need a couple different ones here. Add file command actually doesn't have an L file. Instead, we just have it broken into components. One happens to be string path name and int size. Add directory command. This would just be string name. Change this to name. Oh, and they should be capitalized because C# likes capitalized on public members, which I like. I like that. It's a nice way to distinguish. Yeah, I wish I was good at F#. I did it for 2 days. I did F# for 2 days and realized I kind of hate the syntax. I don't know how to do the idioms well, and I don't have enough time to finish maybe I did. Maybe I would have more time. I would like to get good at F#. I fell in love. I come from Java, and I used C# and fell in love with C# and thought maybe I could do the same for F#, but F# just made me sad. Add directory command, which will just have a string name. Oh, sorry, which just pass in tokens of 1. And then here we're gonna do return new, add file command, tokens of 1 and size. Okay, all right, I don't need to actually process anything. I just need to translate them to commands like that. And then the idea here is command will have a abstract void process command. And this is gonna take in our stack, or our current working directory, CWD, and it's going to need a registry of paths to be able to look stuff up. So I think very functionally. So my problem with F# wasn't that I couldn't think functionally, it was that the syntax, the type system was fighting me. The type system, and I hated the syntax for doing type annotations. It just looked gross. I spent a lot of time doing F# but came back to C#. I think while I love F#, the F# specific libraries for are not good enough that they don't have critical mass, so they go stale or overly optimized. Yeah, so I actually posted a question on the F# subreddit asking, what book should I read? I have a strong functional programming background. I've done a ton of Haskell, like real world Haskell stuff. I've written web servers, done machine learning. I've written an image processing library in Haskell, so I've done a bunch of stuff in Haskell. I understand how to approach things from a functional standpoint, how to organize. But I was just wondering, what are the idioms in F#? Because I can't seem to get the type system to agree with me on certain things. I keep having to do explicit types, whereas Haskell, you tend to have like very generalized types. And you have type classes, which are a little bit different than classes. So I asked, is there a book anyone would recommend for idiomatic F#? And they recommended, I got it, I read it, I've been reading it. Stylish F#. And the very first chapter, or like even the introduction, the author, I forget the name, but the author essentially says, F sharp, there's not a lot of people writing in F sharp, so there's not a lot of good documentation on how to code in F sharp, so it's sort of a wild west of it. And I was like, nah, this is the exact problem I was trying to solve, so it hurt a little bit. So we're gonna have our current working directory. We need to be able to update our state here. So stack of elf directory, paths, and then we also need a registry of all of our dictionary string to elf directory registry. All right, so each one of our commands needs to be able to do this. Is abstract, but it is contained in a non-abstract abstract record. Okay, so now each one of these I should be able to hopefully implement. List command is the easiest. Process command just does nothing. Anyone else really sad with how long this this screen is? I am. And what is this warning? Declare types and namespaces. Oh. Yeah, that's probably true. Add directory command. All right, so this one, we're gonna get our top directory. So string full path is equal to path.peak.path plus slash plus name. And then when you say wrap the parameters, are you suggesting I do this? Is this the idiomatic C# thing to do? I think my formatter, my formatter does like that. All right, cool. I almost did this, but I thought when I ran my formatter, it would chunk them back up, but it doesn't. So that's pretty nice. All right, so my full path is here. I need to create an elf directory. Child is equal to new elf directory full path. Need to add that to my registry. Full path goes to child. And then I need to add that to my parent directory. So I'll go ahead and pull out elf directory, parent or CWD, peak, CWD.path, and then CWD.add child, child. Nearly everything in F# can be done nicely in C#. Only super nice things in F# has is computation expressions and F# type providers. Yeah, I need to look into all of those things. My thought, so one of the things that's really cool about Haskell is you can very, very easily, and I've done this with my image processing, if you write all of your code using map filter reduce, you can very, very nicely dump it onto a GPU or pass it off to something that can parallelize it very, very easily. And so my thought is, well, can F# do that? And I guess I should do some research. But if you're purely functional and you know, and you manage all that stuff, it's very easy for a compiler to say, oh, this is how I'll compile it to the GPU. I know F# not purely functional, but you know if a function's purely functional, you have to like sort of mark things as whether or not they mutate data and have side effects. So the process command here is gonna peek. We get our current working directory. We get our full path to our new child. My directory should probably end with slash. I'm looking here, this is an issue because root starts as slash. So I'm gonna actually make all of my directories end with slashes at the end, just for consistency. Okay. The other thing that's really nice about Haskell is all of these, there's some great extension types, and I love the automatic generation of unit tests. For the most part, you can automatically test a lot of things just because it makes the type system make sense. Type system allows it to do that. Add file should be, this one should be pretty easy. Oh no, I don't want those there. paths.peak.addChild new file or elf file. Path on the children don't actually matter that much. Maybe I should just do name on them. I'm gonna try that name, and then I'm gonna regret this, aren't I? I'm gonna need this size here. I suspect I'm gonna regret doing that and not pulling out the full path. But my register, I really only care about directories, I think. Although later on I might need the full path to them. Let's go ahead and get the full path. Full path is name. There's no slash at the end, and then we'll do full path. So this is my current working directory. So this just becomes cwd.addChild, like so. And then the change directory command here. Let's copy this stub here. This should just look up. Don't give me hints, Keith. No hints unless I ask for them. If I get stuck, I'll ask for them. I should probably be doing more testing here. I'm using that logic muscle a little bit too much here, trying to think through it before I'm done. I really should be testing each one of these chunks, but where's the fun in that? Where's the fun in that? So we're gonna get our full path out here. Oops. Get our full path. So we're gonna look up in our registry, full path, and we're just gonna push this paths.push that on there, unless we have a cd dot dot. So if we have a cd dot dot, we actually pop. So we're gonna say if registry, or sorry, if name is equal to dot dot, we're gonna pop paths dot pop, else we do this format. If you really want to give me a hint, go ahead. You've already saved me once. You saved me once, so it could save me some pain, actually. All right. Maybe give it to me here. Okay, so my question is, can I process some input? Let's create an input file new, input.txt. We'll do this one here. There we go. Trying to second guess is the fun part. So I actually shouldn't push my root here. So I'm gonna actually skip. Before I start this off, I know I'm starting with cd root, so I'm actually just gonna DQ once here to ignore that initial one. And then I called the c.process command paths All right, so yeah, this should be my paths and then my registry, which I haven't created yet. So my registry should be dictionary from string to elf directories, registry equals new. And then what am I doing here? I need to add in registry.add root. All right, let's see if my program runs .NET run. See if it just crashes. There's no argument given. All right, I have an actual. Dot equals root. The given key /A was not found. Correct. All right, let's look here. Risk over engineering the first part versus completely rethinking the second part. That's sort of what I went for on this. I was like, well, I could probably just do this with like a giant dictionary of paths to something and then do it. But I decided I'm not going to risk the second part. All right, here we go. Console.writeLine command. We die on dirt A right away, it looks like. But let's see. No, we get all the way to CDA. We get all the way to CDA and then we die. Oh. I know why. Let me change my elf directory. It's because I have... This is full path. So... Alright, let's look here. Change directory. Oh, this is interesting. When I get to an add directory. Full path. Change directory. I'm missing that little bit there. Yeah, I'm not trying to get on the leaderboard. That's way too stressful. Okay, so my program didn't crash. I did way too much coding without testing. My students would hopefully none of my students ever watch this because I always yell at them for not testing ahead of time. So I only yell at them for not testing ahead of time when they ask for help, and I come over and I say, okay, my program doesn't work is what they say. I say, well, what have you tried? And said, well, here's my program. It's a whole program. I said, okay, well, what test do you have here to check whether or not it's working? The answer is always none. Okay, so now for my root, to give myself confidence, let's go ahead and let's override the toString for elf directory. So that way we get, that seems like it's gonna be a lot of work. I was gonna say, maybe I should write a thing that gives me this out. That seems horrific. I guess what I could do is just check my size of directory. Okay, so for each elf directory, string path in registry. Hang on, registry dot. They're like key pair. What is it if I? Is there an iterator for registry? One of the C-sharpers I follow is the core maintainer of XUnit. Nice, and doesn't test either. He actually did a follow-up of one and tried to show it via TDD. So I do these beginner guides on YouTube. So I've done a beginner guide so far for all of them, and in each one of those I try and have a little test ahead of time. It's not a unit test, but it's just like a print line test. Say, okay, give yourself some confidence that it's going to work. And then I give them sort of a method or a function stub, and I say, okay, try and implement it. And then there's like an 8-second pause that has some hints on the screen. And it comes back and I show my solution. I should, usually when I'm programming, I will, but I'm not doing that right now. Is there, so I want to look at dictionary. Yeah, so if I just for each here, var, like that, L. What is the type here that I'm getting back? Key value pair. Key value pair from string to elf directory. Okay. L dot value console dot write line L dot value. Look at that. That looks pretty good. The images for my YouTube videos, Dolly does them. I basically take my narration and pass it into Dolly, and it generates the intros for my videos. I select which ones I want, but I essentially have Dolly generate the intros to my videos. Okay, I think this looks correct as far as the sizes go. Let me make sure. E has 584. Yep, 584. Yeah, you can tell. So Dolly, in Dolly, the bottom right corner, usually, this doesn't always happen. Let's go check. I'll show you real quick how you can tell it's Dolly on these videos here. In the bottom, oh, it's hard to tell with the bar over it. There's these signature. Dolly has a signature, which is, I think, these colored cubes that go across the bottom. I'm not sure if you can see them in this picture here. Let me mute this so it's not too loud, but if I play, you see in the bottom right corner, there's the little Dolly signature with the little dots, little squares. All right, let's get back to it. I just wanted to verify here that my sizes looked valid, and they do. So now find all directories with a total size of 100,000. All right, so this one now I just go through and find all of these. So I can do registry dot values dot where directory d dot size greater than 100,000. Is it greater than or equal to? Total size of, find all directories with a total size of at most. Oh, that's interesting. At most. And then sum up the total sizes of those directories. Dot sum. Can sum take a function? It can. So d goes to d dot size. So int sum console dot write line sum. That's weird. I figured we were looking for giant files that we can delete, right? All right. So this would be the sample input. All right, let's try mine. See, moment of truth, right? Everyone cross your fingers for me. Hey, gold star for me. Look at that. All right, I'm happy with that. I like gold stars. Oh boy. Now you're ready to choose a directory to delete. The total disk space available to the file system is 70 million. It didn't find my bug. Oh no. To run the update, you need unused space of at least 30 million. 30 million. You need to find a directory you can delete that will free up enough space to run the update. Oh, thank you. I probably, ooh, that's interesting. I don't know if I would have caught that. I don't know if I would have caught that. Thank you for pointing it out. Thank you for giving it to me here. In the example of the total size of the outermost directory and thus the total you can delete that will free up enough space. In the example above, the total size of the outermost directory and thus the total amount of used space is this much. This means that the size of the unused space must currently be this much, which isn't quite the amount required to update. Therefore, the update still requires a directory with total size this much to be deleted before it can be run. To achieve this, you have the following options. Directory E and A are both too small. Deleting them would not free up enough space. However, the directory D and / are both big enough. Between those two, choose the smallest, increasing unused space by this much. Find the smallest directory that, if deleted, would free up enough space. What is the total size of that directory? Okay. All right. I guess I could have done this using a dictionary. But I've engineered it in a way that I think will be relatively easy to find. So I'm trying to find my total space. All right. So I have an int here, total space, and I like to do this to keep myself sane. Counting zeros is not a fun exercise. Int required space is total space minus registry.values.sum. Oh no, register. All I care about is my root dot size. I almost made a grave error there. It's the required space. My root size tells me the size of everything. And so I'm gonna sort these smallest to largest. So registry dot values dot. There's no sort. There's no sort to array dot to list dot sort. And I think that should give me. I gotta tell it how to sort them, right? D goes to D dot size. Do I have to tell it a pair? D0, D1, D0 minus D1 dot size. This should give me the order. Does this return a new list? It just actually sorts it. Ugh. Hang on. I gotta do list of elf directory dirs.sort string.join new line dirs. Tell me here. Oh, I gotta actually print that out. Console.writeLine. Do I get my biggest directories or the smallest? Looks like it's in the right order. The bottom one is the biggest. So it gives me some confidence there. Did a little minor test. Then we're just gonna do dirs.first. That matches D goes to D dot size is greater than or equal to required space. So this should give us an elf directory to delete. And then finally, we can just print out console writeLine to delete. Tell me, who should I delete? Well, that can't be right. That can't be right. Wants me to delete. All right. That can't be right. Let's see here. Something terrible has happened. Oh my god, that's not the right input. Let's try this input real quick. Honestly, I should have a second file. File, new text files. Let's create an example. Example.txt. Let's put this in there. Let's try example. Wow, it really is saying I gotta delete my root directory. That makes sense, maybe. Maybe that makes sense. I don't want to delete my root directory. Oh, I've sorted it above. I did a sort here. So I sort them from smallest to largest initially, and then, oh, you're saying first may not guarantee order from that list? That's an interesting thought. Here, let's look at this list here, and let's see if that makes sense. That makes sense. We're gonna print out all of these directories. Let me print out my required space console, and before here, I'm gonna see if the second largest directory is big enough here. So we'll do. I could also just pass in that number and see what happens. Space required. Oh, this also. Hang on, I'm wrong. Required space is 30,000. That's what's going on. I just had the wrong calculation for required space. I need 30 million. Hang on. I need 30 million. Yeah, I just have the wrong number here. For sure, the wrong number there. My required space is 30 million. So I need to calculate how much space do I need to free. So I have int current space is total space minus root dot size. So this is my current space. My required space is going to be what is that? The difference. Let me print it out real quick because my brain is too tired to do this math. What do I need here? If I print it out, maybe it'll make more sense. Current space and required space. Print those two things out so my brain can look at them separately. Yeah, so I need to free up the difference there between required space minus current space. There we go. You're right that it may not be in order for first. I suspect my gut tells me that would go that way, but you're right, it might not. Should be in order. My gut tells me the implementation, usually you want your implementations to kind of make sense. But just to be sure, we'll do console.writeLine space required space like that. We'll soon see. That's right, Smab. Required space. Well, the funny part. All right, let's switch this back to input. Don't give me my root. All right, now give me a real directory. That makes sense, and we can kind of go backwards here. From top until we get to that one there. All right, let's try it. Hey, hey, 2 gold stars. 2 gold stars for me. I get to celebrate with my 2 stars. All right, we're building up a jungle here. Smab, let's check out your solution. Oh, let me commit this real quick. Let me break it up into 2 parts here because we actually had void part 1, just so that void part 1, and then void part 2, and the important bits are here. I can comment out those. Okay. All right. Yeah, I'm looking forward to seeing your guys' solutions. Get status, get add, get status. And I was told that I shouldn't add my personal input to these. Get reset input. Which makes me a little sad because if the site disappears, I won't have my inputs anymore. Git commit -m chore hacked solution for day 6. Day 7. Yeah, I was told by whoever on Reddit is like Dragon something said, so I'd posted a link to my repository and they asked me to remove my personal input file. Yeah, and it's exactly that reason, Keith, that I think multiple people, like you said, there's curated sets of inputs that have been tested by people. So that would make sense. All right, we're gonna go for another 20 minutes here, which should give me time to admire solutions that are far superior than my own. Zoom in a little bit so we can see it a little bit better. Is yours in one file day 7? Oh, one file day 7. Who am I looking at here? This is Smab UK's submission. Parse and create, total with less than. It's a big name. It's an apt name though. It tells you what it does. I did add mine to Git too. I've added it on every day except for today, as per requested by Dragon something or other. So let's look at here. Essentially, total of subdirectories less than. Okay. And then we have this one here. I'm so happy to see I'm not the only person that does this. I've had people say, that's weird that you do that. I love that feature. Most programming languages actually have it. I think even C has it with the underscores in between. Maybe not C, but I feel like there are versions that do. Same thing with parse and create, calculate the space to free up, select where. Ooh, this is nice. This is nice. I like that. I like that better than mine. Smab, you're better than me, and that's okay. Because you know what? I'm good enough, I'm smart enough, and gosh darn it, people like me. I like this a lot. Really like that. It's the same, but I like that you didn't have to sort of create an intermediate sort to do it, because there's no sort on our enumerator. Link doesn't have a sort as far as I could tell, or maybe it's called something different. All right, parse and create. You have a class called directory, or you're just using, yeah, directory here. Order by, that's what I should have done. Thank you. Duh, SQL's order by. I just want to sort it. Oh, I gotta be better. I really gotta get better at C#. Directory, string name. I did too much, I think, with having them be subclasses. I don't think I really utilized it except for the commands, and that was a little bit overkill on the commands. But I like the string name. You keep track of your parent, which is good. So I'm imagine you, when you get a dot dot, you just say, oh, go to my parent. That's probably better than what I was doing, if I'm being completely honest. Then I don't need a registry. I like that. I had sort of set into how I defined it. A lot of times just having a good, the way you're modeling your data is super important for how your solution will come out. That's what so when I go to write my tutorial video, I'm probably going to clean it up a little bit, because I'm trying to keep them semi-language agnostic. So I am using C#, but I try and say, okay, well, but here's how you would do it. So I don't really want to have too many, I don't want to sort of push someone into using object oriented. So I'll probably end up with something called add child that takes in a directory and then a file, and then one that also adds in the directory. But I like this with the parent, making traversal back up easier. Size becomes easy. Yeah. Well, I mean, because you're trying, you're modeling the data. That's really what it is. You're trying to model the data that you're given. This is a really, really, I like your solution, Smab, very much. Yeah, my initial thought was like, I could do this really cheating thing where I just use a dictionary to keep track of everything. But that's right, we didn't know it was coming for part 2. I didn't want to railroad myself into a corner, which is, I think, one of the struggles students, at least with my students have done a couple days now. And if you don't have a good approach on the first part, you end up in this weird corner, and it's almost like this, you're like, well, I want to keep using what I have. And you end up breaking everything. This is a really nice solution. This method does everything it needs to do. I usually tell my students that if you can avoid nesting stuff, you should, but this seems like a semi-appropriate time to have those nests. I'm not a big fan of code going sideways. If you can avoid code going sideways, and which is the whole reason I ended up building this command type class. It's like, well, I don't want to nest too much. But in my commands, how much nesting did I get in here? I think all my nests are sort of, I don't think I have any nesting. Yeah. I try and yell at my students a little bit if they get gnarly with the nesting. I usually tell them at most two. At most two. If you start going past that, there's some abstraction we need to do. Really nice solution, Smab UK. Thank you so much for sharing it. I am definitely gonna use this as a little bit of inspiration for my cleaner solution when I go back and refactor it for my tutorial video. Keith, let's check out what you got here. You have a file system. All right. File system. Oh, that's a far better name than what I came up with. File ref. File system makes sense. Maybe even file system ref. File system. That seems really obvious after the fact, as opposed to file ref. Good name. Folder string parent. Everyone used parent except for me. I'm the fool here. Ooh, interesting. IEnumerable. IEnumerable items. Item in folder. What am I looking at here? Item in folder. File system. Oh, item is folder. I thought it said in folder. I was really confused. This is the pattern matching I was looking for. This is nice. This is nice. If item is folder, do this, else return item. This is, I really like this, Keith. The one downside, and I like that you've sort of trapped them all inside a file system. I like it. I like it. I like it a lot. Solve here. Yeah, that's what I was saying. Like, this is really pretty recursion. I sort of hid, I think I hid my recursion in a select, right? So my recursion is just, I added the children to this thing and then I let select sort of get the size of them, and that recursively does it. So I don't actually have like a like an explicitly recursive size calculation or file system explorer. It's just I have children. I really like this. All right, solve. For every line, if it starts with this, if it's a command. This is how I feel. I feel in the morning, I literally wake up in code. I think it's a good way to like jumpstart your brain, get yourself going for the day. So I wake up and start coding, but you guys always see me sort of dazed a little bit, not quite there. It's a nice way to write my first draft for going back and then talking my students through it. So I'm almost certain today I'm gonna have students who have looked at this and have questions. So it's gonna be really good for me to have finished it, so I can start answering some questions. If it starts with this, then you do a switch on ls or cd. Okay, so this sort of goes through, it parses. What am I returning here? Turns the folder. Oh, Smab, you got to get more than 4 hours of sleep. That's no good. Sleep is so important. So I have, in the past, when I was in grad school, I did that. And it just kills you, it burns you out. And it really, really puts you in a bad place. So I'm gonna encourage you to do whatever you have to do to get more sleep. 4 hours is just not enough. Building up some gnarly sleep debt. This is nice. I'm trying to understand file system folder. Our parse, where's our? Oh, this is an internal function. So this is back, a parse of file system. Okay, so this is building up the whole file system as we go here. This is a little tricky to look at. At a glance, this feels it's straightforward, but it requires you to think. In my mind, there's a bunch of branching here, doing a thing, returning this, returning that. Pay for it in your table tennis. That's good. Nice solution. I almost did. Yeah, because you build it up as you go. This is a nice solution. I would, if my student wrote this, I might tell them, depending on the level of the student, I might ask them to sort of break it down into logical chunks that are easy for me to read as a viewer, someone reading through it. I have to go in and try and grok through what exactly this is doing, but it's not bad. It's just slightly more effort for me to look at than I want. I want to know at a glance, what is this doing? And then if I need to, go in and look at the details. Yeah, this is a little bit tricky to follow exactly what's going on. So again, the indentation, there's so many indentations here. Like I said, I usually limit my students. I say at most 2. If you have more than 2, you should try and pull it out. but sometimes it gets the job done, right? Nice work here, Keith. Nice job, Smab. Am I following you on GitHub? I've already started this. Make sure I'm following you. There we go. I'm gonna follow you, Smab. And Keith, I'm already following you. All right, everyone. Thanks for hanging out with me this morning. This was nice. This is a nice way to wake up, get myself going. There's five minutes left before I really got it going, so I don't really have time to hop into anything. But I'm happy to entertain you in some way if you would like to be entertained. I don't know how I might do that, but otherwise, I'm gonna hop off here and get myself started for the day. I am teaching some classes today. Got to put together my tutorial video. Got to refactor this to be a little bit more beginner friendly. I'm stealing the directory knowing about its parent. That just makes sense. Sleep well, Smab. Get more sleep. Sleep as much as you can. We'll see you next time. Have a beautiful day. As always, keep coding. Keep making yourself grow and be better. And you're welcome back anytime, of course. All right, everyone. Have a beautiful day.